Welcome to my project update on the wireless home network monitor. Let's get started with the introduction to this project. This project started with the need to know where your data is going, where it's being used at. Um, this is very much important when you're using a metered data connection. Um, Metered data connections, for example, are used in remote locations, mobile homes, or even at locations such as homes where it's more feasible to have a wireless broadband connection as opposed to a wired connection. This pairs in together with the growing popularity of IoT devices such as um, smart watches, smart bulbs, smart, for example, door locks, uh, all which compete for internet usage, as does your traditional laptops, phones, and desktops. Current solutions for analyzing networks include solutions such as the PRTG network monitoring software. Um, However, the biggest problem with this software is that it's aimed at network professionals, meaning that the information provided to the user can often be complicated, it's not user friendly, and the most important factor, it's very complicated to set up and use. Um, it can also affect the device which it's installed on, and thus often requires a dedicated device to make sure that your network slash device does not suffer any detrimental um, usage. So my project aims to develop a user-friendly and cost-effective solution to monitor the network. As the project stands right now, the Raspberry Pi works as a router which accepts internet connectivity through its Ethernet port and then uses its onboard Wi-Fi module as a Wi-Fi AP to provide internet and also monitor the usage of connected devices. Um, right now, the Raspberry Pi isn't capable of being connected to wired devices. However, this problem can easily be fixed by purchasing a USB to Ethernet module and thus using your router as a bridged connection uh, to allow the Raspberry Pi to still handle the routing and the network monitoring, but also be capable of serving Ethernet devices. Uh, so the core of this project lies in the popular Linux application TCP dump, which is capable of listening to network requests over a specified interface and then pushing it out onto a file or pipe. Um, as the Raspberry Pi is being used right now, there are two main components, two main functions that we need to look at. One is stream TCP dump and the other one is a create file. Both of these are asynchronous functions, which meaning that they run at the same time. One will be processing out the information from the TCP dump onto a file, while the other one will be creating a new file every specified time interval. Um, Once this file is created, it'll then be uploaded to an Amazon AWS 3 bucket. Uh, the Raspberry Pi is configured as such. It has a host APT application running on it, which allows us to use the Wi-Fi module as a wireless access point. It's configured as a WPA2 compliant Wi-Fi network at 2.4 gigahertz. Um, Other than that, it also provides a DHCP server, meaning that you don't need to assign static IPs or devices connected to it. The Raspberry Pi will take care of all that and provide it a IP between the ranges of 4.20 to 4.2. Sorry, 4.2 to 4.20. Yes. Um, so that's how the Raspberry Pi is configured right now. Going on, this is what the output from a TCP dump command looks like. We can see the source in red, the destination in yellow, the length of the file in green. The port numbers of the file of the destination and source can be seen as um, the last point, the last numbers after the stop over here. We can also see the type of the packet, and all this information can later be passed into meaningful data. This is what it looks like on the S3 bucket. Um, every single time a file is uploaded, it can be viewed and downloaded from here manually, or we can use an API that Amazon provides to download it manually to an EC2 instance. Speaking of which, let's look at what the next steps are towards project completion. Um, Pretty much a lot of what's required from the Raspberry Pi right now has been handled and implemented. The next we'll be looking at downloading those aforementioned files from the S3 bucket to an offsite EC2 instance. We'll be parsing the information from the EC2 instance and then adding it to a NoSQL database. The reason why we chose a NoSQL database is because it's um, very good at handling inserts into the database, and there isn't really much relational data needed over here. And finally, we'll be presenting this data using a dashboard. Um, the reason why I'm using a second Dairy server to do all the processing is because the Raspberry Pi should only be handling the routing capabilities of the network and also just pushing out the data via TCP that comes on the TCP dump. Uh, we do not want to take away any of its limited processing capabilities, and thus we're just offloading it all onto a secondary EC2 instance. Uh, that concludes the presentation. Thank you for watching.